All right, this video went way too long the first time I did it, so I'm going to try to go a little quicker through the material here, and if I have to, I'll stop it at 10 minutes and make a part 2, just because YouTube only allows me to upload 15 minutes. So let's get going here. Right away, we're 15 seconds in, and Lesson 8 is all about parabolas. You kind of know them in the past. You've seen them. They look a little something like this. Curves where they have a vertex and the curve, it's symmetrical, but this is a little different. We're now going to be talking a little more about a focus point somewhere where that focus point to the parabola is the same distance as that point down to a line we'll call the directrix. So let's get going a little further here, but when we're all done with this, here's what it's going to look like. This is a little spoiler alert. We're going to have an equation that looks like this. So when you're done watching the video, come back here. This is what it's going to look like. Y minus c squared. And that c comes from right here. This directrix line, y equals c. And then we've got x minus a squared. That's the difference. That's the distance between the x coordinate of the point, which is the focus. That's over here. And any coordinate on the axis. Or excuse me, on the axis. I'm reading, not talking. Any point on the parabola. And then the last piece of it is y minus b squared. And that's the difference of the y's. That's from any point on the parabola to the y coordinate of any point that's the focus. So let's see what this looks like, okay? So we're going to jump in here. Right away, we're going to say, here's point F. That's a focus point. If we connect that to point A, that's got a distance to it. And what the parabola formula says is that that distance from that point to the focus, that's D1 there, and then the distance from the point down to the line on the directrix, that, by the way, is the directrix right there. And that line, if it's the x-axis, it's just y equals 0. Those distances are equal. That's the whole point. That's what we're saying, is that these things are equal. Big aha moment. That's just definition. Now, what do we do with this thing? How do we actually do some calculations? Well, we're going to use the distance formula, but not exactly as it's written. It's written like this. We've seen it as this square root of this sum of squares. You know, we had the x's and the y's. We had, kind of x2 minus x1 and all that fun stuff, and y2 minus y1. Well, if we square both sides of that, we're going to look at really the distances squared. It's much easier to compare those things. I mean, we could actually solve using the distance formula and say, are they equal? But it actually is equal to square both sides. So if I erase this, I end up with the distances squared. And that's what we kind of really want to look at. And in the x category, it's x minus a squared. And the reason for that is that if you look right here, I'm going to point it out in a second, is that this point over here, this focus point, we use the coordinates a and b as the coordinates of the focus. And we use the coordinates of the point on the parabola as x and y. So what we've really got is we're just looking at what's the difference in the x's right there, and we're squaring it. So it's that Pythagorean thing again, but it's just the difference of the x's is what that is. And then we come over to the y's, and we say that's going to be y minus b squared. And same thing, it's this y coordinate here minus b. It's the difference between the two y's, and it's squared. And then when we look at the right side of the other distance here, from the point down to the directrix, that's kind of this down right there, it's just a change in y. It just goes from the y down to c. So that's why we usually write this over here as y minus c. Now in this case, it's actually the y-axis, c is 0. So then we calculate it. We actually do the calculations, and let's do one of these together. I'm at 4.5 minutes here, so this is probably going to be part 1 of this video. There'll probably be a second part. I don't think I can go faster. I want to cover the whole lesson. So here's what we're doing. We're saying, no longer are we saying distance squared. We're actually writing that as y minus c squared. Okay, well, here's y is 5. C down here is 0, so 5 minus 0 squared is 5 squared. That's 25. Okay, so that's the distance squared of this vertical piece here. And then on the other side, we've got x minus a. So on the point on there is 2. The x-coordinate of the vertex, or not the vertex, the focus, is negative 2. So 2 minus negative 2, that's actually going to be 2 plus 2, if you think about doubling the negatives there. So that's going to be 4 squared, or 16. And then we're going to add that to our y minus b here. Well, y is on the graph, that's 5. Our b is the y-coordinate of the focus point, that's 2. 5 minus 2 is 3. 3 squared is 9. And guess what? 16 plus 9 is not a magic number. It's 25. What that does is that tells us that the distances are equal, and that proves that that's a parabola. That proves that it's on the parabola if those distances are equal. That's the whole idea. So we're using the distance formula a little more focused, if you will, to make a little pun there on the focus point. So that's the equation of a parabola in what we call focus directrix form. It looks just like this because that's exactly what it is. Focus directrix form. That gives me A and B, the coordinates of the focus, and C, the y-coordinate of the directrix. All right, because it's just a y line. Okay, we're at 6 minutes and 41 seconds, so let's keep on plugging away. You can always pause and rewind that. We got more, folks. Here's a parabola. It looks like a parabola. It's got a focus point right there. It's got another point over here. And it's got, once again, this directrix. It's y equals 0. And we know that as kind of that C there. So they're asking us to rewrite this equation into vertex form down here. Now, if you look down below, you'll see that vertex form. We got an H and a K here. We call that A, that B, that X, that Y. Where in the heck did H and K come from? Pause the video for a moment. Go read the summary at the back of the lesson, and then we start the video, okay? Because we got to go to the summary to answer that question. We just can't do it right here, right now, okay? So pause the video, go back, read the summary, come back, we'll take a look. Okay, you read the summary, so you probably went back to the summary and said, wow, what happened here? There's just the definitions. That's just looking at, hey, you can see right here that this is the difference x minus 1. That's the difference between this focus coordinate, and by the way, they should put the coordinates on here. It's actually 1, comma, what's our y coordinate there? 4. So that's the difference of our x's. So that change in x, it really is truly the change in x from the focus point to the point on the parabola. And then we look at the other side of that and we say the y's over here, it's y minus 4, because that's really, literally, y minus that b. We called it b before, but we were using numbers now. So that's how it looks. And then because this distance from the y coordinate of the parabola down to the directrix line, there's no change in x. So that really is just the change in y. That's why it's kind of just y squared. It's just this y coordinate of 4 minus 0. So what we really don't see there is that 4 minus 0 squared. So the question is, how do we get that into a vertex form? Because you know what the vertex is. You can see it right here. It's right on the graph. It's the low point on the graph. It's right there. Let me highlight it. It's right there. So let's go over to this section right here and say, wow, okay, here's the steps. I'm going to outline them here, and I'm going to stop the video, and then we're going to come pick this up in part 2. So here's the steps. There's our original equation. You can see what happens. The x term gets left alone. It gets left alone. It gets left alone. We don't need to worry about the x's because that is already in x minus h format. All right? So that's already in that format. That means that the vertex coordinate actually is 1. That's how it's going to end up happening. Now with the y's, we got a lot of different y's. We got two y's here. We got a y and a y squared. So we got to actually expand the y's. So the first step is to expand or multiply out all the y's. And you can see they did that. They did y minus 4 squared. So that's y squared minus 4y doubled. That's minus 8y plus 16 because that's minus 4 squared from the last lesson. And then at that point, what happens is, it's kind of nice. The y squareds, if you subtract y squared from both sides, it cancels off. So it does go away like that. I mean, I'm crossing it out, but I'm subtracting it from both sides. And then when that happens, that's why we're subtracting. I'm actually going to write it in here. Y squared from both sides. When that happens, now we're getting closer to y equals. We're trying to get this y equals equation down here at the bottom. That's the Holy Grail. We're not quite there yet. That's where we're trying to get to. So what else has to happen? Well, let's see what happened here. This is literally step by step. Step 1, expand the y's. Step 2, subtract y squared from both sides. Step 3, you'll notice, is we're moving this 16 over. Actually, we're not moving the 16 over. They did this a little weird. They moved the x minus 1 term right here. They moved it over to the other side of the equation. They moved the 16 over to the other side of the equation. So they actually moved all x terms. And actually, you know what? I'm going to say this a little differently. I'm going to use mathematical language here. Isolate y. That's what they did, truly. They isolated y. In other words, they moved x minus 1 squared, they subtracted it. 16, they subtracted it. So that's how you're getting to this next level down here. And you can see it now. It's minus 8y equals minus the whole thing, x minus 1 squared, minus 16. And the last step is to divide by negative 8. So that's the last thing they did. Or what some people like to say is multiply both sides of the equation by 1/8. That's the same thing. And then you've got to multiply, you've got to actually divide by 8, divide by 8, and divide by 8. And that's how you get it. And that's now the vertex form. That's what it looks like. So I'm going to go back and rewrite that, stop the video, and come back. So it's y equals, we usually put an a, like that number in front, that 1/8. We call that a in this equation. X minus h squared plus k. In other words, we can see the vertex and we can see a few other things. But right now it's just, we call it vertex form. And that's why we do that. It's vertex form because we can see h and k are the vertex. So in this case, the vertex is 1 and 2. And we're going to pause right there and stop.